Now that we've worked with radical, or not radical, rational equations, we're going to work with radical equations. So we know that a radical is a square root. In our case, we'll just be working with squares because we're in the quadratics of our section here. So we also know, and we've kind of worked with this a little bit before, to undo a square root, we square it. Okay, so for instance, we're going to start a little basic for right now. If I were to have the square root of 4x, and that equals, let's say, 8. So the first thing I'm going to do is I'm going to get rid of that square root. In order to get rid of the square root, I square. In order to do that, I also have to do it to the other side. So when I square the left side, this cancels out. So I really have 4x equals. Well, what is 8 squared? That's 64. Now that I've got rid of my square root, I can just solve this algebraically. So then I would divide by 4 and x equals 16. So this one was a basic example, but let's get a little bit more challenging here. Let's say, for instance, that I now have the square root of x plus 2 equals 4 minus x. So in this case, I have two different variables, and I need to figure out what happens. So again, I'm going to get rid of the square root by squaring both sides of the equation. Now that square goes to everything on the right side. I have x plus 2 equals, a lot of people will say 16 minus x squared. What I'm actually going to do is I'm going to list the 4 minus x twice and then distribute. That way I know for sure that I'm taking care of everything. So I have x plus 2 equals 16 minus 4x minus 4x again, and then plus x squared. A lot of people, again, will do 16 minus x squared and call it good. But you need to make sure that you're using that parenthesis twice and actually distributing that information out. So now I can solve this like any other quadratic. I'm going to rearrange this a little bit so my exponents are going down in descending order, but I'm going to move this x minus 2 over as well. So I've got 0 equals x squared. I have negative 4x, and negative 4x gives me negative 8x, minus an x from the other side, so I have minus 9x. I'm subtracting 2, so I'm at plus 14. So I can use a couple different ways. I can use factoring. I can use completing the square, the quadratic formula. I can use all those different options. For this one, I'm going to go ahead and factor. I need the factors of 14. And I see that if I have a negative 2x and a negative 7x, that's going to give me that negative 9. So I have x squared minus 2x minus 7x plus 14. I'm going to go ahead and group this. Looking at the second grouping, I know that they have a negative 7 in common. Notice inside my parentheses is the same, which is my goal here. I'm going to go ahead and break this up. X equals a positive 2, and x equals a positive 7. Okay, so the overall goal here The only thing that's really new is the first step. I have to square everything to begin with. Okay, so for you guys, I have the square root of 3x plus 7 equals x plus 3. So looking at this, I'm going to go ahead and square both sides. So I have 3x plus 7 equals, again, I'm going to list the x plus 3 twice, as I do not want to make that mistake again. So I have 3x plus 7 equals x squared plus 3x plus 3x plus 9. All right, so I'm going to go ahead and combine my like terms and move them all over to the right side. So 0 equals x squared plus 3x minus 2. So looking at that, the 3x gives me the 6x, but I'm minusing 3x again, so it's okay. So now from this, you can use a couple different ways. You can complete the square. You can also quadratic formula, you can factor. I'm going to go ahead and complete the square just because I know it's another method that we need to practice. Looking at this, I have 3 over 2 squared, which gives me 9 over 4. This goes down to x plus 3 halves squared. And then on the other side, 17 over 4. I'm going to take the square root of that. That equals x plus 3 halves. I'm actually going to reduce this a little bit differently here. I'm going to split this. So I have x plus 3 halves equals positive square root 17 over 2. Some of you are probably wondering where I got the square root 17 over 2. What is the square root of 4? That's 2. That's why I got rid of it. And then I have x plus 3 halves equals negative square root 17 over 2. I'm going to subtract off the 3 halves. And work on the right side here. Now, depending on the method that you chose, you will still get the same answer. I know this wasn't exactly the prime condition to use, but it is good for you guys to use your quadratic formula or to use completing the square or factoring or whatever method you are choosing. You need to be open to all of your different options. Okay, so that is all about radical equations.